Chapter 1, Experimental Chemistry. Volumes of liquids SI unit, cubic meter, m superscript 3. Large volume measurement, decimeters, dm superscript 3, 1 dm superscript 3 equals 1000 cubic centimeters. Daily life measurement, milliliters, ml, or liters, L, 1 liter equals 1000 milliliters. Apparatus for measuring liquids depends on 1. The volume being measured. 2. How accurate the measurement needs to be. Beaker hold approximate volume of 100 cubic centimeters and 250 cubic centimeters. Conical flask holds approximate volume of 100 cubic centimeters and 250 cubic centimeters. Measuring cylinder has accuracy to 1 cubic centimeter. O reading to be taken nearer to the meniscus, bottom line. O, if reading is 23 cubic centimeters, should not write 23.0 cubic centimeters as the 0 means accurate to 0.1 cubic centimeters. Burette has long scale of 0 to 50 cubic centimeters, accurate to 0.1 cubic centimeters. O, liquid level to be measured before and after tap opening. The difference of volume gives the liquid volume poured off. Bulb pipette measures exact volumes such as 20.0, 25.0, or 50.0 cubic centimeters, not odd volumes such as 31.0 cubic centimeters. Volumes of gases measured with gas syringe, up to 100 cubic centimeters. Temperature measured with thermometer. Two types are, 1. Mercury in glass. 2. Alcohol in glass SI unit, Kelvin, K. Daily life measurement, degree Celsius, degree C, K equals degree C plus 273. Time SI unit, seconds, S, other units, minutes, min, /hour, H. Measured with clock. Digital stopwatch mass, the measure of amount of matter in a substance SI unit, kilogram, kg, other units, grams, g/milligrams, mg, large volume measurements, tones, T, 1 tone equals 1000 kg measured with electric top pan balance. Triple beam balance methods of purification and analysis. Pure substance, single substance not mixed with anything else, e.g., white sugar, copper sulfate crystals, distilled water. Mixture contains 2 or more substances. Its quantity is more on Earth. E.g., seawater, salt, water and dissolved solids, milk, fats and dissolved solids. Obtaining pure substances. Purification, the separation process of mixtures into pure substances by using physical methods without chemical reactions. Filtration, separates insoluble solid from a liquid. Mixture is poured through a filter with tiny holes made of paper. Large solid particles cannot pass through the pores and trapped in it as residue, while tiny liquid particles pass through as filtrate. Crystallization and evaporation to dryness. Crystallization, separation of dissolved solid from a solution as well-formed crystals. Evaporation to dryness, separation of dissolved solid from a solution as crystals of salt by evaporating all the liquid off. Full overview process. Why crystallization occur? Solubility of most solutes decrease as temperature decrease. When solution cools, solution can't hold more solute, saturated, so the extra solute separates as pure crystals. Sublimation, separation of a mixture of solids which one of it sublimes, by heating the solid mixture to turn one of the substance into vapor without going through liquid state. When mixture of iodine and sand is heated, iodine sublimes, turns into vapor directly, then cools and crystallize when it reaches cold water area. Examples of sublimable solids, CO2, S, dry FeCl3, S, dry LCl3, S, simple distillation, separation of pure liquid from a solution by condensing vaporized liquid, condensed pure liquid, distillate. Process of distillation. Solution is heated, and steam, pure vapor, is produced. The steam is cooled in condenser to form pure liquid. Solute remains in the flask. Fractional distillation. Fractional distillation separates mixture of miscible, soluble, liquids with widely differing boiling points. Use of fractionating column separates them. Process of fractional distillation, e.g., ethanol and water. Mixture of ethanol and water is placed in flask and heated. Ethanol with lower boiling point boils and vaporizes first and reach fractionating column, then cools and condenses into ethanol as it passes through condenser. Temperature will stay constant until all ethanol is distilled. Water will distill the same way after all ethanol is distilled. Uses of fractional distillation. Separates pure oxygen and pure nitrogen from liquefied air. Separates substances in petroleum, crude oil, into fractions. Separates alcohol to produce alcoholic drinks. Reverse osmosis. Reverse osmosis separates a solution, example seawater, by pressurizing the mixture against a membrane which separates the solute and the solvent. Reverse osmosis. Reverse osmosis separates a solution, e.g. seawater, by pressurizing the mixture against a membrane which separates the solute and the solvent. Seawater is pumped under great pressure into a closed container onto a membrane, forcing water particles but salt particles to pass through. Some salt particles may still pass through. Use of separating funnel. Separating funnel is used to separate immiscible liquids. Two liquids insoluble to each other will create two layers of overlying liquids of each type. To separate, take the stopper off and turn the tap on to run the denser liquid at the bottom off the funnel and leave the less dense liquid in the funnel by turning the tap off and reset the stopper at its original position. Chromatography. Chromatography, a method of separating and identifying mixtures. The need for chromatography. Separates and identify mixtures of colored substances in dyes. Separates substances in urine, drugs and blood for medicinal uses. To find out whether athletes have been using banned drugs. Separating mixtures of colored substances. Obtain a dye sample, then put a drop of the sample on a pencil line drawn on the filter paper, then dip the paper into a solvent with the level below the spot. The dye will dissolve in solvent and travel up the paper at different speed. Hence they are separated. Identifying mixtures of colored substances. Drop of sample dye is placed on pencil line. The result shows that the sample dye is made of 3 colors. 2 comparison dyes are of one of the compositions of the original dye, as the spots are of same color and distance. A comparison dye isn't part of sample. Separating and identifying mixtures of colorless substances. To do this, a locating agent is to be sprayed on filter paper. Locating agent, a substance that reacts with substances, e.g. sugars, on paper to produce a colored product. RF values to identify unknown dye. In the diagram at the very top, RF value equals XY, where X equals distance moved by the substance and Y equals distance moved by the solvent. Checking the purity of substances. Pure substances have fixed melting and boiling points. Pure water boils at 100 degrees Celsius and melts at 0 degrees Celsius. Impure substances have no fixed melting and boiling points. They melt and boil at a range of temperatures. OEG starts boil at 70 degrees Celsius, completes boil at 78 degrees Celsius. Black small square also, it can vary melting and boiling points of pure substances. Black small square, e.g. pure water boil at 100 degrees Celsius, but with salt is at 102 degrees Celsius.